Welcome back to the shop. If you've been following the channel, you know that I've been trying to make new adjustment knobs for my South Bend Steady Rest. In the first two parts of this series, I machined the interior features of the three adjustment knobs and then made an arbor so that I can machine the exterior features. So now I can move on with the next step. I have one of those blanks, I'll call it, threaded onto the arbor, and I'm ready to turn it down to its final major outside dimension. In almost every case with these parts, the dimensions really are rather non-critical. I got the dimensions from some folks online, and I'm trying to make this part at least come close to what the original part would have been from South Bend. So the outside dimension here is a little bit more than 1.5 inches. I'd like to take a quick second to thank the subscribers of the channel. There's so much good content out on YouTube, and you still choose to hit that subscribe button for my channel. Your support really does mean a lot. And for those that are brave enough, in each of the descriptions for my videos, I provide some links to some other ways that you can also support the channel. And one of those other ways to support the channel is through Patreon. I kind of like the Patreon model in which you're not just giving somebody a donation for nothing in return. There's different levels that you can donate at. And one of the levels that I set up on Patreon gives you access to all of the CAD files and drawings for these parts and for some other parts that I don't normally make available on my Etsy shop. And if that's something that you're interested in, I'd hope that you take a look at those links in the description. Of course, after you've watched this video, given it a thumbs up and left a comment, and take a look at what they are and whether or not it's something that you'd want to do. Well, maybe I'm getting a little bit better at this. I was shooting for 1-inch 526 thousandths and got 1-inch 527 thousandths. I'll take that. I am going to be knurling the majority of this outside diameter, and I'm not sure if I need to have a super clean surface finish or not, but I'll take a few seconds at least to try to sand down some of the rough spots. One of these days I need to get some rolls of emery paper in different grits. I'm sure I could improve this finish even more, but for now this will have to do. Well, back to my favorite color, Dykem blue, on the exterior. I want to do some layout lines for the smaller diameters on each end. The bottom 300 thousandths will get turned down about 86 thousandths from the main diameter, and there will also be a groove, 125 thousandths width groove, machined into that same space. The top ½ inch will get turned down to about 7/8 of an inch in diameter. And to mirror the original, I'm going to put a groove that's about 100 thousandths deep, about 1 inch down from the top. I'm going to start first with this left-hand turning tool with a CCMT carbide insert to take down that bottom 300 thousandths, about 86 thousandths deep. And of course that corner of that insert has a giant chip in it. It's a brand new insert. I just got it from Shar's and just put it in. It must have hit up against something in the drawer of my toolbox. I'm not sure exactly how else it would have gotten chipped because I haven't used it yet. Brand new insert, already broken. Well, as much as these things cost, I'm glad at least I get 2 corners out of this tool turned at 180 degrees, so we should be good to go. This is such a small area, I'm not going in very deep, so I'm going to just feed the carriage by hand. Well, my target was 1 inch 440 thousandths, and I must have screwed up because I managed to get that spot on. You know, my dad used to say that even a blind squirrel will find an acorn every now and again. I'm just going to come back into that shoulder and clean that up without advancing the cross slide at all. I can take out this left-hand turning tool and put in its twin right-hand turning tool with the same CCMT insert. I'm going to be turning down this top ½ of an inch to about 7/8 of an inch in diameter. I do want to put a radius in the corner of that transition. So I need to be careful that I don't take away too much material at that spot, that I won't be able to use the radius tool to give me that softer transition that I'm looking for. I used a piece of high-speed tool steel to grind this radius grooving tool to about 125 thousandths wide. I'm going to use it to not only machine the radius here in this corner, but also to machine a groove near the bottom of the knob. I still have a few thousandths to take off of the diameter here and a little bit to take off of the face of the larger size. So I'm hoping that this tool will be able to do both operations. I think I'm getting this chatter here because I don't really have enough side relief for this to adequately cut the face, and every time I get in close, I think there's just too much material there that it's hitting. So I'm going to have to likely take this back out and do a little bit more of a side relief grind before I machine the other two knobs. It's definitely not the right tool that I want for this job, but I do want to clean up that face. So I'm using my cutoff tool just to try to get a little bit better surface finish. I'll revisit this later. I've got a couple of ideas that should make this better. We'll swap out that tool for a 62.5 degree neutral DCMT insert so I can go ahead and chamfer some of these hard edges. Well, I've got the grooving tool back into the tool holder. I am setting up the lathe in back gear and running at one of the slowest speeds. I'm going to cut this groove near the bottom of the knob, and it's going to be about 128 thousandths deep. So I want to make sure that it's running good and slow so that I can minimize any chatter and get a better surface finish. So I'm going to be using lots of oil. I have the carriage locked, and I'm just going to be feeding it in nice and slow. And if I do get any kind of chatter, I back off on it real quick and then again more lubrication, and then slowly feeding in, I should end up with some pretty decent results. Although it is a pleasing look, this groove is not an aesthetic feature. There's actually a function for it as well. In one spot on this groove, I'll be drilling a 125 thousandths hole that will go all the way through to the threads on the inside. And inside that hole, there'll be a brass shoe. And then a ring will fit inside the groove that holds the brass shoe up against the threads of the adjustment sleeve. My assumption is that this provides enough friction between the knob and the sleeve that during normal operation it will help prevent the knob from backing off. With the main machining operations complete, I can now set the lathe up to do the knurling. The majority of the exterior of this knob will have a diamond knurl in it. I bought this tool from Shars, and it seems like it's a decent quality for what it is. It did have one thing I had to fix though. It was too thick for my 5/8 inch BXA tool holders, and I ended up using my shaper to go ahead and shave down a little bit on the top and the bottom so that it would fit inside this tool holder. I'm taking some extra time here to try to make sure that the height of the knurling tool is exactly or as close to exactly on center with the part as possible. Trial and error on some scrap has basically taught me that if I can't get those lined up and engaging with about as much force equally between the top and the bottom, that I'll end up with an off-balance knurl and it'll just look terrible. Some experimentation has also shown me that I'm best off if I run the lathe relatively slow and with lots of lubrication. I start by advancing the tool slowly until I see both wheels turning, and then I will advance the cross slide dial until I'm met with a considerable amount of resistance. In my previous experiments with knurling, I've had to be pretty aggressive on the cross feed dial in order to get a decent knurl. I honestly don't know if that's normal or not for these push-in type knurlers. But what I think I would much rather have would be a scissor type knurler where the wheels are on the top and the bottom of the part being machined. I don't know, there's just something a little bit uncomfortable with putting this kind of force perpendicular to the spindle. Maybe it's normal, maybe it's okay, it just doesn't feel right. I'm not getting a ton of deflection, if any. It just seems strange that that's the way that this would have to work. I can't get a decent knurl without putting a lot of pressure on this tool. We'll stop and take a quick look at what kind of results I'm getting, and disappointment doesn't begin to actually describe what I'm feeling. It doesn't look good at all. I'm hardly getting any knurl at all. It's almost as if it's barely scratching the surface. When I made the locking knobs for the steady rest, I didn't film that. I didn't feel like I had to exert any real pressure on the part. Perhaps it was a softer material. I don't know what any of this material is made from. It came from a closed machine shop, and none of the stuff was labeled. I'm going to keep trying to get better at this, but if you have any tips on how to use this tool properly, please drop a comment down below, because I would really like to understand what I might be doing right or what I might be doing wrong. So the only thing I can think of doing is applying even more pressure on the cross slide and keep working the tool slowly back and forth, and hoping that that improves my results.
That is horrible.
Well, this is not going well at all, and I would really hate to think that I'm going to end up ruining this part, or at least its appearance, after all the work that I've put into machining it to this point. Well, I doubt seriously, after thinking about it, that I'm going to be able to do anything to break this lathe by applying even more pressure on the cross slide. And if the part's going to get ruined, it's going to get ruined. There's really not much I can do about that. So at this point, I'm going to just go for broke, and I'm going to apply as much pressure on the cross slide as I can, and hope I don't break anything, and hopefully that will get me some better results.
Well, it's improving.
Well, much to my surprise, this is improving. It's looking a little bit better. It's not great, but it's looking a little bit better. So I guess I'm just going to keep on keeping on, and hopefully this will gradually start to look better and better. Well, it may not be the quintessential diamond pattern, but it's actually not a bad knurl. I think I like it. So I'm going to call this good and move on to the next step. Well, this next machining step, I believe, is purely aesthetic. We're going to come about a half of an inch down from the top of the knurl, and using a cutoff tool, I'm going to cut in a groove about 100 thousandths of an inch deep. The next thing I want to do is put a small chamfer on either side of the knurling. So on the top, the bottom, as well as on either side of the groove that we just machined. I think a knurl looks so much better when it doesn't just stop at a hard edge, that it either has a flat transition or has a chamfer on it. And I think that top edge would look a lot better if it was rolled over. So I'm just going to use a standard file. I don't have any decent files yet. Someday. To roll over that top edge. And then I'll also skim it across the knurl to break off any sharp burrs that might have been left from the knurling process. Use this soft foam sanding block to clean up any remaining tool marks. Try to give it just a little bit better surface finish. And now we'll see whether or not I can unscrew this from the arbor. Well, I knew it wasn't going to be that easy, so I'll lock the lathe into back gear, and hopefully that'll give me a little bit more leverage. Well, hopefully putting a rag over top of this will keep the finish from getting damaged, but I'm not sure what other options I might have right now. Well, that came off a little bit easier than I was expecting. Hopefully the other two will be just as easy. With the lathe work finished on this part, I am very happy with how it turned out. The knurling was a little bit tough going, but quite frankly, I think it was worth the effort that I put into it. Well, I've got the lathe work done on these three parts, and I am very happy with the results. Are they perfect? Not by a long shot. Are they good enough for me? Sure they are. I think to the naked eye, they look pretty damn good. Yeah, the knurling on the one on the right here is a little bit better than the one on the left, but it is what it is. And if I compare it to the 3D printed part, yeah, the dimensions aren't perfect, but that's okay. I wasn't expecting them to be, but I do think it is a really close approximation to how I designed it in Fusion. I still have a couple of small machining ops to do on each of these. The cross hole in the ring groove, as well as the cross hole in the top for the taper pin that holds the adjustment screw in place. But those are going to have to wait for another day. If you enjoyed watching this video, please give it a thumbs up. Thanks again for watching, and we'll see you on the next one.